And locations of volcanoes. This is going to be the first video in our volcanoes unit. We'll start by defining what a volcano is, looking at the molten material that comes out of them, and then seeing where they are in the world. So let's start by defining a volcano. A volcano is any weak spot in the crust where molten material, magma, can come to the surface. So it's a weakness in the crust where this molten material underneath is able to come out onto the Earth's surface. And let's talk quickly about that molten material. So we have two names for it. We have magma and lava. And the difference is basically where they are located. So magma is a molten mixture of rock-forming substances, gases, and water that comes up from the mantle. It's basically just melted rock. So when we heat rock up enough, it melts into a liquid. When that is underground, we call it magma. So make sure we know that magma is always underground. When it reaches the surface and comes out and starts flowing on a volcano or flowing on the Earth's surface, we call that lava. So this picture on the right here would be an example of lava. We'll talk when we talk about types of volcanoes, the different types of lava, but any molten rock on the surface is lava. And where do volcanoes form? This is what we're going to spend most of the time on tonight. We're looking at 3 different locations where volcanoes can form. They can form at divergent boundaries, convergent boundaries, or something new called a hotspot. So we've learned a little bit about these two before, and we're going to add in this third thing tonight. So let's talk about at divergent boundaries. All right, so at a divergent boundary, volcanoes form along a mid-ocean ridge. Right? This is where seafloor spreading is taking place. Lava pours out of the cracks on the ocean floor, building new mountains and new crust, but they can also form along rift valleys. Right? So as the continent splits apart, that creates weaknesses in the crust that magma can force its way through. So it's a little weird to think about that in this valley you might have a couple tall mountains as well because the magma has pushed its way through. But there are several along the Great Rift Valley in East Africa. Mount Kilimanjaro, Mount Kenya, these are all volcanic mountains in origin. All right, the next way we can get volcanoes is at a convergent boundary, and we can get them at convergent oceanic boundaries as well as oceanic continental. All right, and again, you do not need to write all of this text. Don't copy it all down. Not a good use of your time. All right, this is just a summary of what we already know. Right, at 2 oceanic plates collide, the older, denser plate subducts through a trench. Some of that rock melts into magma, and it rises to the surface and breaks through, forming a volcano. Right, as that volcano grows underwater, eventually it will become tall enough to get out of the water and be above the surface. And we get a whole string of these called an island arc, right? So in the Caribbean, right, the Virgin Islands, and then all of these other islands down here are all volcanic in origin, right, along with the Aleutian Islands in Alaska. Right? You can see there's a big trench. As the Pacific plate goes under, it melts, and we get volcanic islands on the other side. The next way is still at a convergent boundary, but we have oceanic converging on continental. The oceanic plate will always subduct under the continental plate. We know this. And then it melts and comes up to form a volcano. So Mount St. Helens in the U.S. is an example of a volcano that formed this way, right? And this is still very active, right? Before 1980, the volcano came basically up where my mouse is, and then it exploded off in a huge eruption, but now you can see it's starting to grow up again and continues to erupt. Our last way we can get a volcano is new, and this is called a hotspot. A hotspot is just an area where material, hotspot, not hot sport, is an area where material deep in the mantle rises and melts, forming magma. So it's basically a plume of magma pushing up from the mantle and just punching a hole through the crust. We don't totally understand where these or why these exist. That's definitely still an area of current study in geology. But we do know that they're there because we can see the effects of them. So these volcanoes don't have to be at a plate boundary. Some of them can be in the middle of a plate. Sometimes they are at plate boundaries, but they definitely don't have to be. And so a hot spot on the ocean floor can end up forming a series of islands over time as the plate moves across that hot spot. And you can also have them under continents. If you've ever been to Yellowstone National Park, there's a huge hotspot under Yellowstone, and that heat keeps all the geysers and hot springs working. And eventually, and we have evidence that Yellowstone can actually erupt and has erupted in the past. And so examples of the hotspot, right, with Hawaii, the only active volcanoes today are on the Big Island. If we were to go back millions of years, the island of Maui would be where the Big Island is today, and that island formed over that same hotspot. But as the plate moves up to the northwest, it carries these older islands with it. Right? So this is the newest island. There's actually a new island forming off the coast that's still underwater today. All right, that is all for locations of volcanoes. All right, make sure you put 3 questions down, and we'll see you guys in class on Monday.